All right, so get ready because we're going to dive into LLMs, those large language models everybody's talking about.
Right.
We've got this research survey all about instruction tuning for large language models. I got to say, it's a bit much, even for me.
It's dense.
Yeah. But hey, that's what we're here for. We're going to break it down, pull out the good stuff about how to make these LLMs even better because honestly, they're already kind of amazing.
Back to the research, that's for sure.
Totally. So, okay, what's the plan for this deep dive? Where do we even start?
So basically, our mission is to really understand this instruction tuning or IT, why it's a big deal for LLMs, how it works, the nitty-gritty.
Okay, I like it.
Oh, and we've got some interesting data sets and kind of surprising results to unpack along the way.
All right. Sounds good. Let's do it. So we've got these LLMs. They're super good at predicting what word comes next, right? But how do we go from that to something that can follow actual instructions, like write me a poem in the style of Shakespeare?
Okay, so yeah, it's actually really interesting. Imagine a dog that fetches a ball because it's been trained to, right?
Right.
That's your basic LLM. Now imagine a dog that understands, go make me a sandwich. That's kind of the leap we're talking about with instruction tuning.
Whoa, hold on. A sandwich making dog. That's a whole other level.
Exactly. Instruction tuning is it's giving these LLMs a comprehension boost.
Yeah.
They go beyond just recognizing patterns to really grasping what we mean, responding to much more complex instruction.
Okay, I see. So it's not just about fetch anymore. It's full on understanding. All right, so let's get into this instruction tuning a bit more. The research paper mentions natural instructions. What are those?
So natural instructions, they sound simple.
Right.
But they're really about teaching LLMs the little nuances of how we actually talk and write. Think about the difference between, say, a good question about event duration.
Okay, event duration.
And a bad one.
I'm curious. Give me an example.
Okay, so let's say we have the sentence. After a long day at work, Sarah was exhausted. A good question about event duration would be, how long was Sarah at work? You see, it's implied, but not directly stated.
Right. It doesn't say how long.
Exactly.
So a not so good question would be was Sarah at work for 8 hours? Because we don't know that from the sentence.
Exactly. And the natural instructions data set, it's full of these kinds of examples to help LLMs really understand all those subtle ways we communicate.
That's really cool. It's like teaching them to read between the lines a bit.
Exactly.
Okay, now this supernatural instructions data set, what makes it so super?
Well, for one, it goes way beyond just English. We're talking 76 tasks across 55 different languages. It's like they're trying to teach an LLM to be a master communicator.
Wow. Across cultures, everything.
Yes. It's a huge step toward LLMs that can work with, people from all walks of life, different backgrounds, languages.
Yeah, that makes sense. We can't just have them be good at one language, right? So, okay, we've got these data sets with all these instructions, but how do we actually use them to train an LLM? The paper mentions something called distillation, which makes me think of chemistry class, honestly.
It's a good analogy. Think of it like a brilliant scientist passing their knowledge to a student.
Okay.
So we're training a student LLM using a much bigger, more powerful teacher LLM.
Like an AI mentor or something. Is there a specific LLM that often plays the role of the teacher?
Yeah, actually, sometimes it's ChatGPT.
Oh, wow.
Researchers are using it to train smaller, more, specialized LLMs. And get this, the research talks about how with these data sets like Orca, these smaller LLMs can actually do better than models 5 or 10 times their size.
Wait, really? That's wild. It seems backwards.
It really shows how powerful distillation can be.
Huh. So it's like quality over quantity in a way.
Exactly.
Okay, but distillation isn't the only method, right? There's this self-improvement thing, which sounds almost too good to be true.
It does, doesn't it?
Yeah.
But it's real. We're talking about LLMs that can actually create their own training data.
Hold on. They're learning to learn on their own. That's kind of blowing my mind right now. So the paper gives an example, spin. It uses a self-play mechanism. What does that even mean?
It's like having two versions of the same LLM playing a game against each other.
Okay.
And this helps it figure out the difference between its own answers and the ideal answers. And that leads to some serious self-improvement.
Wow. It's like having a built-in AI coach constantly pushing it to be better.
Right.
But this whole self-improvement thing, while cool, the paper does say there are potential downsides, right?
Of course. One worry is that if the first LLM, the one we're using for self-improvement, if that one has biases, they could actually get worse during this process.
So it's like garbage in, garbage out, but amplified.
Exactly. We really need to start with a solid, unbiased LLM to begin with.
Makes sense. So we've got these data sets, training methods. It's a lot to take in. But how do we know if it's actually working? How do these instruction-tuned LLMs measure up?
That's the real test, right?
Right.
We need to look at the LLMs that have gotten this instruction tuning upgrade and see how they compare to what came before.
Right. Give me some examples. The paper mentions InstructGPT quite a bit. What's the story there?
InstructGPT is a real success story for instruction tuning. It's a version of GPT-3, but it went through this intense instruction-based training. And the results were kind of amazing.
Okay, like what?
Well, compared to the original GPT-3, InstructGPT was way better at following directions, staying on topic, and just avoiding, those nonsensical outputs that LLMs sometimes give you.
So it's like taking the raw power of GPT-3 and like focusing it, giving it a bit of direction.
Exactly.
The paper even says that InstructGPT was better at, telling the truth, sticking to the facts.
Right. It shows that instruction tuning isn't just about making LLMs more obedient, it's about making them more reliable.
Which is really important, especially with all the talk about AI hallucinations these days. It's one thing for an LLM to, ramble a bit, but if it starts making stuff up,
That's a problem.
That's a big problem. So what are researchers doing to deal with that? Is instruction tuning part of the solution?
It's definitely part of it, yeah. One approach is to actually build fact-checking right into the training process. So by training on data sets that really emphasize accuracy, we're trying to teach these models to know the difference between what's real and what's not.
Like teaching them to be more skeptical.
Yes. And this emphasis on truthfulness, it's in that truthful QA data set we talked about earlier. It's designed to challenge LLMs, make them really prove they can handle the truth.
Interesting. Okay, now the paper also mentions this other potential downside of instruction tuning, superficial learning. What is that?
All right, so this is where it gets a little tricky. Some researchers worry that maybe instruction tuning is making LLMs really good at, playing the game, but not necessarily at truly understanding.
So instead of actually learning, they're just figuring out how to give us the answers we want.
Right. It's like teaching a student to pass a test by memorizing without them actually grasping the material.
Yeah, okay. So it's not just about acing the test, it's about actually knowing the stuff.
Exactly.
So are we building really smart LLMs or just really good mimics? That's a tough one.
It is a tough one.
What are researchers doing about this superficial learning problem?
One idea is to move beyond just giving LLMs instructions. We need to incorporate more context, more reasoning.
Teach them the why behind the what.
Exactly. Like imagine teaching a kid how to solve a math problem. You wouldn't just give them the formula, you'd explain the concepts behind it.
Right. So they actually understand it. Okay, so we've talked about some potential downsides, but before we move on, can we get into more examples of LLMs that have shown improvement with instruction tuning? The paper mentions BloomZ and FlanT5. Have you heard of those? I've heard the names, but I'd love to hear more about them.
They're really cool examples of how instruction tuning can boost what we call zero-shot performance. It means these LLMs, they can do well on tasks they've never even seen before.
It's like, what's that saying? Give a man a fish and you feed him for a day.
Teach man to fish and you feed him for a lifetime.
Right.
That's what BloomZ and FlanT5 show us. They can adapt, tackle new challenges.
Because they've been trained on such a wide range of things.
Exactly.
That's seriously impressive. The paper also mentions Alpaca, Vicuna, and Claude as examples of instruction-tuned LLMs. What can you tell me about those?
So each of those demonstrates different instruction tuning techniques. Alpaca was trained on a massive data set of instruction following examples.
So again, it's like learning from the best of the best.
Right. And Vicuna is interesting. It was trained using real conversations between people and ChatGPT, not just made up data.
So real world stuff.
Yes. And it worked. People consistently rated Vicuna as being more helpful, more accurate compared to other models. It even did better than Alpaca sometimes.
Wow. Okay, what about Claude?
Claude was designed with the focus on being, helpful and harmless. The researchers who made it, they really prioritized training it to avoid toxic or offensive output.
So it's like ethical considerations built right in.
Exactly. Making sure these LLMs are a force for good.
Which is so important because, as we've been talking about, these things are powerful.
Right.
Okay, there's one more thing I want to touch on. Low resource instruction tuning. What is that?
So this is about training LLMs when we don't have tons and tons of data.
Which seems tricky.
It is, and it's especially important for, say, languages or fields where huge data sets just don't exist.
Right, like if you're trying to teach an LLM about some obscure topic.
Exactly. But researchers are making progress. One technique is called LoRA, short for low-rank adaptation.
Laura, kitschy.
It's a way to fine-tune LLMs more efficiently without needing mountains of data. And then there's delta tuning, which focuses on fine-tuning specific parts of the LLM instead of the whole thing.
So being more strategic about it, it's
yes.
like researchers are always finding these clever workarounds. Okay, before we move on, I do want to touch on multimodality. It's like the next big thing, right?
It is. Imagine LLMs that can process not just text, but images, audio, even video.
It's like going from black and white to like full-on VR.
And the research points to some early work being done. There's this data set called Multi-Instruct with 62 different multimodal tasks.
Wow, 62. What kind of tasks are we talking about?
We're talking about LLMs that could, say, answer questions about pictures, generate captions for videos, maybe even write scripts for movies.
That's wild. Are there any LLMs that can actually do that now?
So one model, OF, was trained on that Multi-Instruct dataset, and it did show real improvement in its zero-shot performance across different multimodal tasks.
So early days, but promising.
Yes, and there are others. Instruct Pix to Pix, for example. It can follow really detailed image editing instructions.
So you could tell it, make the sky in this picture more dramatic.
Exactly.
That's so cool. But that's just images. What about other types of input?
Right. Lava is another one. It combines visuals and language. It was trained on a huge data set of image-text pairs, and it can do things like image captioning, answering questions about images.
So, like, you could show it a picture and ask, what kind of bird is this?
Exactly. And it can tell you.
That's amazing. It really feels like we're on the edge of something huge here.
We are. And this is just the start for multimodal instruction tuning. The research even highlights Video Llama, Instruct BLAF, and LAM as, like, other avenues to explore.
So much to explore. It's incredible how fast this field is moving, but it makes you wonder, what are the real-world implications of all this?
Right. We've seen how powerful these LLMs can be. How are they actually being used?
Yeah, let's get into that. The paper mentions some domain-specific examples, like dialogue systems and information extraction.
Exactly. Instruction tuning isn't just about these super intelligent general LLMs. It's also about making AI tools for specific fields.
Specialized LLMs. That makes sense. So let's start with dialogue systems. What are some instruction tune models for that? The paper mentions InstructDial.
Yeah, so InstructDial is a good example. It was trained specifically on instructions for, like conversations, evaluating how good a conversation is, figuring out what someone really means when they say something.
So it's like teaching an LLM to be a better conversationalist.
Exactly. It's about making those interactions feel more natural, more engaging.
Right, because nobody wants to talk to a robot. We want AI that can actually hold a conversation.
And InstructDial did really well, even with very little information to go on.
That's impressive. Okay, what about this information extraction thing? The paper talks about InstructUI for that.
Right. So InstructUI is all about getting specific information from a ton of text. Imagine you've got like a mountain of documents and you need to find certain facts. InstructUI can do that.
It's like an AI research assistant.
Exactly. And it actually outperformed several other models, even GPT 3.5, which is impressive.
Wow. Okay. So we're talking about potential game changers in fields like research, journalism,
Even business.
Right. It's amazing to think about how instruction tuning is already being used to solve real problems, and it feels like we're just getting started.
We are.
But, before we get too far ahead, I think it's important to step back and look at the bigger picture. What does all of this mean? Where do we go from here?
Those are the big questions, aren't they? Instruction tuning might be new, but it has the potential to completely change how we see AI.
It's like we're moving past those simple commands to a place where AI can really understand us, work with us.
It's about making sure that AI is helpful, trustworthy,
responsible.
Yes.
Because this technology, it's powerful.
Incredibly powerful.
And speaking of powerful, that brings us to the thought-provoking idea the research paper leaves us with, the idea that we've only just started to explore multimodal instruction tuning.
It's true. We've talked about some amazing stuff, but there's so much more to come.
Like what? Give me a taste.
Imagine LLMs that don't just understand text and images, but also audio, sensory data. Imagine an AI that could experience the world through all of our senses.
Whoa. Like it could watch a movie, listen to the music, and understand it all.
Yes, it could learn to recognize emotions in music, understand body language in a video. It's incredible.
But also kind of a lot to think about. What happens when AI can not only understand our emotions, but maybe even manipulate them? That's a whole other conversation.
It is. And it's a conversation we need to have. As we develop this technology, we need to make sure it's used for good.
Absolutely. We need to be thoughtful. You need to be careful. But one thing's for sure, this is going to be interesting.
It really is. It's about AI that doesn't just work for us, but with us. And hey, maybe someday we'll have those sandwich-making AIs, right?
I'm holding you to that.
Mhm.
Okay, so we've talked about a lot, but I want to dig into this idea of like specialization within instruction tuning. It's not just about making LLMs good at everything.
You got it.
Just-
Like, any field, you've got your generalists and your specialists. Same with LLMs. We're seeing a lot of research on how to tailor instruction tuning for specific things like medicine, law, even creative writing.
Right, because a medical LLM is going to be totally different from an LLM that's like writing the next Hollywood blockbuster.
Exactly.
So what are some of the challenges there with this specialization?
Well, one of the big ones is data. You need the right data.
Makes sense.
Like if you're training an LLM to, say, understand legal documents, you need a ton of legal documents.
It's not just random documents. They have to be the right kind of document.
Exactly. And they have to be labeled correctly, organized in a way that the LLM can learn from.
So it's not just about quantity, it's about quality too. It's like you can't learn to play basketball by watching tennis.
Exactly. So researchers are finding ways to get around this data problem. One way is to take those big general LLMs and then fine-tune them on smaller, more specific data sets.
So it's like they've got the basics, now we're sending them to grad school.
Right. And it's been working. Researchers have been able to get good results on things like medical diagnosis just by fine-tuning those general LLMs.
Even with limited data.
Even with limited data.
Yeah.
Which is really promising.
That's amazing. Imagine having like an AI assistant that's an expert in your field.
Right. It could change everything.
It really could. But if we're going to have all these specialized LLMs, how do we even know if they're any good? And how do we evaluate them?
That's a great question. Because you're right, the usual ways of testing might not work.
Right. It's like you can't judge a fish by its ability to climb a tree.
Exactly.
Yeah.
So one idea is to get experts involved. Like if you've got a medical LLM,
Yeah.
have doctors test it out.
See if it actually knows what it's talking about.
Right. Compare its diagnoses to their own.
So it's about combining like the AI knowledge with actual real world expertise.
Exactly. And that kind of collaboration, it's going to be crucial as we move forward with all of this.
Yeah. Okay, so we've got specialized LLMs. We're thinking about how to train them, how to test them. It's a lot. But it's exciting, right? There's so much potential here.
There really is. And honestly, this is just the beginning. Instruction tuning, it's not just a fad. It's changing how we think about AI. It's going to have a big impact.
No doubt. And speaking of big impacts, I keep coming back to that final thought from the research paper that we've barely scratched the surface of multimodal instruction tuning.
It's mind-blowing when you really think about it. Right now, we're mostly doing text, images. But what if we could bring in audio, video, sensory data?
It's like giving an LLM a whole human experience, let it watch a movie, listen to the music, everything.
Exactly. And as we explore that, who knows what we'll find?
It's exciting, but also a little daunting.
For sure. There are definitely challenges ahead. But it's going to be an amazing ride.
I'm ready for it. It really makes you think, what could this actually look like? This multimodal future. How would it change things?
Oh, man. The possibilities are huge. Imagine, like, accessibility. LLMs that can basically perceive the world for people who can't.
That would be incredible, to give that ability back to people.
Right. Or think about, like, creative fields. Art, music, LLMs that could work with artists, take inspiration from a painting, a song, create something totally new.
That would change art as we know it.
It really could. And education, too. LLMs that could figure out how you learn best and then adapt to that.
Wow. Personalized learning for everyone. It's amazing to think about. But with all this potential, there's got to be some downsides, right?
Of course. There always are. One of the big ones with this multimodal stuff is data. You need so much data, text, images, audio, maybe even more.
An impossible amount of data. How do you even find all that?
It's a challenge. And it's not just about finding it. It's about making sure it's good data, diverse, representative.
Because if it's not,
then the LLM is going to learn all the wrong things.
Yeah.
It could perpetuate biases.
Yeah.
Make things worse.
So we need to be really careful about what we're feeding these LLMs.
We do. And that's where having diverse teams, diverse perspectives, is so crucial. We need to be thinking about bias from the very beginning.
Absolutely. And as these LLMs get more powerful, more integrated into our lives, what about privacy, security?
Huge issues. We're talking about AI that has access to so much information about us, our online activity, our movements, even our emotions.
It's a little unsettling when you put it like that.
It's a lot of power, so we need rules,
Yeah.
regulations, ways to make sure this data is handled responsibly.
It's a big responsibility, and one that we need to take seriously. Well, we've covered a lot of ground today. Instruction tuning, from the basics to the, honestly, kind of mind-blowing. What are some key things you hope our listener is walking away with?
I think the biggest takeaway is that this isn't just about technology, instruction tuning. It's about changing how we think about AI. It's about collaboration, not just control.
It's about teaching AI to work with us, not just for us.
Exactly. And we're just getting started. Who knows what the future holds? It's an exciting time to be working on this stuff.
It really is. Well, to our listener, thanks for sticking with us on this deep dive. It's been a long one, but hopefully it's got you thinking about the role AI plays in your world and how instruction tuning might change that. Keep those questions coming, stay curious, and we'll see you next time.